Hi, welcome to RedSky. What we're going to do today in this video is go over some of the coding conventions that we have in RedSky and some of the ways of formatting files in your projects and all that kind of stuff so that we can maintain a nice consistent code setup. So the best way to see a lot of this stuff is we've documented them in the RedSky Confluence. You can get there through this URL, RedSky Technologies. Atlassian is the maker of Confluence.net/wiki. When you go there, you'll have to sign up, or if you've been invited, you'll be in there. But Confluence is divided up into spaces. And spaces, you can kind of think of them just as folders of articles and everything. So you might have a developer space or a coding practices space. And just so you know, some of these articles might get moved around from time to time as we find better organization systems. But for right now, they're in the coding practices space. And then we have a number of these articles, such as JavaScript and TypeScript coding and style guidelines. So in this video, this is what we're going to be going over today is the JavaScript and TypeScript coding style guidelines. So go ahead and click on that, and we're just going to go through this article. So a lot of our code is done in JavaScript and TypeScript, and so we wanted to make sure that we had a nice consistent approach for handling JavaScript and TypeScript. We use Prettier for our automatic code formatting, and let me give you an example of what Prettier does. So when you get Prettier set up, you can essentially code away, and you can code kind of however you want. You can put a lot of enters in there. You can say function, test, and depends on whether you want a space after, or maybe you want it smashed up against that as you're typing for your parentheses. And you can say test number, and you can, if you like the curly brackets being the second line, just go ahead and code however you want, but Prettier is going to basically force it back to there. So console.log, test kind of thing. And what you can do is in a lot of IDEs, you can install the Prettier plugin, but it essentially is a little node module that will run, and you can just hit a keyboard shortcut. For me, it's all the key modifiers, so Control, Shift, Alt, and then P for Prettier. And when we run that, you can see it basically formatted it up. It made sure that there was no more than one blank line in between the functions. It brought the parentheses over. So if we do that again and try to make it look ugly again, you just run it again and it formats those lines. So with Prettier, we'll have that running on code check-in as well as you can just run it in your terminal, and it makes it so that everybody has a nice kind of uniform way of formatting. It's a highly opinionated formatter. In programming languages, we use object-oriented classes for a number of things. And so this kind of defines how we like our classes to be laid out. We like, obviously, the class organization to be first public variables or public member variables, and then possibly private member variables. So you can see here there's a public variable in JavaScript, TypeScript, variables without any keyword in front of them are public, and then private ones follow with the private keyword. Types can be defined. However, if you're just going to initially assign them, you don't have to. They can be inferred from the actual assignment on there. After that, after private variables, we'll go into public methods. So you always will put your constructor at the top, and with your constructor, you have to call super if you're extending from a class. And then private methods would follow after that. And so there would be, so again, we still have our public methods and we have our private methods there. With TypeScript, you have the ability to do what they call decorators. So this is a method decorator. And what this does is it binds the this pointer to this class. It bounds the method to this instance of the object that gets created from this class. Now, what does that mean? Well, if you've ever done a decent amount of coding in TypeScript or even JavaScript, classes was added as an afterthought onto original JavaScript. Originally, they didn't have classes, and let me do this. I'm going to create just a quick little TypeScript file. Well, I'll just do JavaScript. And so classes were something that was added after the fact. Before, it was always just functions. You could use functions to kind of wrap and kind of make pseudo classes, and you'd see a lot of things like this, and you'd have this. And what the original keyword for this in JavaScript was defined for was the calling context of it. So remember, JavaScript was originally written, or still is, for web browsers, and so a lot of times you'd do something like a document.query, all kind of thing, and you'd find some sort of ID, and on that you'd do like an on click, and you'd give it a function, and inside that you could say this dot style equals disabled or something like that, or display none, or however you'd want to use it. You'd basically this in the case of here would refer to the element that was actually being called upon, and so in classes, though, there's also this, which could refer to the class instance. So if I have a function or a method of like hello, and if I say this dot, and if I have a member variable of help, and it's equal to hello, you could say this dot, you could say something like console.log this dot help, and it would work for the most part. Normally you'd instantiate your class like this. You'd say something like let test equals new test, and then you'd say test.hello, and that would work, because in this case the calling context of the this pointer is going to be whatever object you have right here, and that would work, and the this would be appropriate. However, this doesn't work if you do something like here, where you say like a set timeout, and you pass in this dot hello after, like, in half a second from now, 500 milliseconds. What you're doing is you're passing in kind of this almost like a function pointer to be called at some later time. Set timeout will assign that to some variable and just make sure it's called. But the problem is that your this is not associated anymore with the original object that you created. And so the way JavaScript has kind of solved that was they allowed you to do kind of this bindings, where you'd say in your constructor, you'd say something like this dot hello equals this dot hello dot bind to this. And that would make it so that anytime you actually ever use that function in this class, the this pointer is in fact always bound appropriately and saved. So now your set timeouts will work and be all happy. But you'll find yourself that you have to kind of do this quite a bit. So JavaScript also has another way of doing it, where you could say constant hello bound equals, and you use the arrow function, not constant, but you could say hello bound equals that. And here's an important thing to learn in JavaScript. There actually is a difference between a arrow function and just a regular function inside of it. What the arrow function does is it'll bind the this pointer to the block context that's here, whereas the function won't do that. It'll bind it to the kind of the global context. So you'll see a lot of people in their classes, they'll kind of do that, where they'll say like hello bound equals that, and they can use this dot help just fine, and it works all the time. However, this just, I don't know, it is kind of ugly. It's a little bit weird looking, and when you compare it to other object-oriented programming languages, you're taking a variable and assigning it to some anonymous function, and it's all just because you're trying to get around the this pointer issue. However, in TypeScript, like I said, we have the ability to do decorator. So we can say bound method there, and it actually, you have to bring in a package like we do. Let's see here. If I go to one of my services, like user service, the bound method package that we have, I might not even be doing it in this one. I'll just add it to one of these bound method. It comes from this auto-bind decorator library that we've kind of used ubiquitous at RedSky here. So I know that was kind of a long deep dive into this pointers, but I think it's really important for developers to know the difference. I really wish that they would have done, like, used the word self or some other term, because they've already kind of messed up the way that this variable was being used. All right, so long rant over. Again, this is how we like our methods to be done, as actual functions or real methods there instead of arrow functions. Typically like to put the input parameters on there with TypeScript and the return types on there. Private methods will just have the keyword private. So let's go over capitalization. There are a few different types of capitalization that you could have out there. There's camel case, and so camel case is like this, where the first letter in a multi-word is lowercase, and then any other ones are uppercase. So it's like all around the world would be kind of like that. That would be an example of camel case. Another casing that is popular is Pascal case. It was kind of used in the Pascal language, and so you'd see that like user service would be a kind of Pascal case. Another one is snake case, and snake case has kind of this underscore approach there, and so you'd have all around the world. We usually try to avoid snake casing in a lot of things, just because the underscore is kind of a pain to hit on your keyboard. And the last one is kebab. Let's just do a kebab case like that. And so it kind of looks like a shish kebab, and so all around the world. And that one you can't usually use in most programming languages, because they'll think of this as a subtraction operator, but it's used in HTML and for sometimes IDs or classes. Again, we won't really use these at RedSky. We will try to mainly stick to Pascal case and camel case. So with that said, just a regular variable, we're going to use camel case, and we're going to try to always use a let. We're not going to use var, so we usually want to use let or constant if the value is not changing. Acronyms, when you have multiple acronyms like ATM, GPS, they get kind of weird when you squeeze them together, and so they get hard to use. So for example, let's read this. So get ATM data for GPS system. You can kind of see like the double S, it kind of goes weird there. So with our acronyms, we're going to do get a capital ATM, but the TM is lowercase, data for capital GPS system. So that's how we'll do our multiple acronyms, or any acronym really. Classes will be in Pascal case, so uppercase there. Namespaces will be in Pascal case. And even though well, we'll get to this. Functions will actually be in camel case, so they'll be lowercase in there. The one exception though is going to be with React components. Typically React components, when they initially started, were in classes and they were uppercase, and that's how the JSX likes to identify React components, as that uppercase. So now that we've kind of shifted over to function-based React components, we're going to actually still keep that as uppercase functions. So they'll be in the Pascal case. Finally, constants are the one case where we will do snake case, but they're going to be all uppercase snake case. And the reason for doing this is we just really want to make them stand out in code, that they are like a constant, like a mathematical value, or they're an enum. And so you'll see enums as kind of this uppercase snake case kind of thing. Next is, how do we do our file and folder naming? What we want to do is always think about what you're exporting from a file. So with TypeScript, we're going to use ES6 imports and exports rather than CommonJS, which is used in Node.js. And what do I mean by that? Well, I mean that we're going to, we're going to have an export default. My function will be like that, and function. And so what we're trying to figure out is, if this was to be a folder with just this file, what do we want to do name convention? Well, the way that we've come up with this is that all folders by default have to be camel case. So they all start lowercase first, uppercase for next words. You look at our components, we'd have like color picker, group page sidebar, all that kind of stuff. For the actual file, the casing of the file is it depends. What it depends upon is the default export. So if you're going to export just a function, the file name would match what you're default exporting. So it'd be a lowercase myfunction.ts in this case. If you're exporting by default a class, so if I exported class, my class, so if that's what you're exporting by default, the file name would be capital myclass.js or .ts if it's TypeScript. And then finally, if you're actually going to, have this class in here, but you actually create a variable of it, so like a singleton of my class equals new my class, but you exported default my class, again, this file would actually be lowercase my class for that. So again, it all depends for the file naming, the uppercase and lowercase, based on what you're doing. And like I mentioned before, if I look at one of these, the folders are always camel case, and here is an example of a React component. In this case, the React component we leave as capitalized, we export that, and so therefore our file name is uppercase there. All right, and I believe this just kind of goes through all the same thing. Exporting a class, we're going to be uppercase there. In JSON, we want to have everything always be camel case, so user ID, user role, kind of camel case, stuff there. And that's it for the JavaScript TypeScript coding guide. Let's go to the HTML JSX coding guidelines. The first is that we want our classes should be always camel case. So if we're putting a class on a HTML element or a React element, it would be camel case like this. If we're doing IDs, now IDs should be something that's used very sparingly. With React, there's hardly a time that you actually really need to use IDs, unless it's some sort of library that's trying to call in and look for a specific ID. But in the case of IDs, we want to make them stand out a little bit more, and so we're going to do Pascal casing on IDs in CSS. We really use Sass more than we use CSS. Sass is just like a superset of CSS and allows us to do nesting, which is kind of the most important thing. And so what we want to do is we want to make sure that all of our React components that we create, they all have everything that's going to be adjusted on them to be nested inside of one and only one root level class. And so let's look at an example of that. So I have this paper pulled up right here. And if you look at the return statement of this React component, we're going to have a class name of RS paper. This is actually a really cool library called class names that allows you to concatenate multiple class names. It takes care of things where the class name's not defined and all that fun stuff. So we will make heavily use of class names function here. That's important from this library. But again, this is the paper. Notice that it has RS. Well, the RS is obviously stands for RedSky. And what we want to do is we want to make it so that top level classes have the RS in it. If I was to do some sort of div down here and do something hello here, the class here should not have an RS in it. It should not have an RS hello. It should just be, hello or content or whatever you want, but that should not have the RS. And the reason for that is if I come here and if I bring up one of the sites that we've worked on before, like shop.trumi.com, say you're a new developer and your job is to fix this bug right here. Why is that arrow overlapping the border, right? If I inspect this, how would you know which component to go to? There's a couple ways. One is to use the React tools that are built in and maybe go find the component. But another quick way, because a lot of times you are just in this elements view, is you just kind of want to look for that RS in front. So an RS icon tells me that that is a component that I can actually go look for in code is an icon component. RS button is kind of the same thing there with the RS button class. RS box. But what I'm really trying to look for is maybe I'm trying to figure out which page I should go and try to fix this issue on. So I'm just going to keep on going up the stack. There's product, there's box, page content right there. So RS page, and I see it's on the shop page. So that kind of tells me that I can go find a shop page that I can start going down this journey of fixing this bug. If we were to take every single div, like these elements here, these are technically labels, and so I might not be able to find a perfect example of this, since in this case we are actually using all of our own components for this. But if you had to find it without the RSA, it was a big page, you could kind of get lost in there. And so we're going to basically say that our labels or our components will have that RS in front of it, but nothing else in there. Now, if you actually go look at the SCSS, you can see that we have our RS paper, and we can go ahead and freely change whatever we want of the stuff that's in here. And so what that allows us to do is not have leakage of CSS values going into other components if we always make sure we follow this convention of wrapping all of our CS styles inside of the component's name and making that the top level value of the component. All right, moving on. Here's our standard folder. Again, camel case folder, uppercase file in Pascal case. This is what a TSX component, so a TypeScript React component would look like. You would have React being imported, the SCSS file being imported, and then we're going to create an interface for all the props that this component needs. And so we're going to name it always the same, test component, like there, but we're going to add props to the end of that, and that will be fed into here. And then we would have this function. It would return a div. Again, it wraps the class name right there and it exports that. Let's see. So one of the things that I find a lot of people doing is they might create a new component. And so instead of having to type that out or copy and paste and get over, a lot of IDEs have smart templates, or live templates is what PHP Storm calls them. And so I've created one called new component. If I just hit tab now, it kind of fills the entire thing out, and I could say my new component. And you can kind of see everything just kind of gets filled out for me, and all my props and all that stuff. So I would heavily look into making sure you use these live coding examples. It really makes completing stuff really nice. Same thing if I do a SAS. I have a SAS, let's see, SCSS kind of thing. It just kind of auto completes, and I can do my new component. All right, pages are a type of component that we use that obviously are a page that you would hit on a URL. They look very similar to a regular component, but they have the word page at the very end, just so we can always find it really easily when we're looking through stuff. So here's an example of an entire, like, more complex TSX file layout. So here we have our test component. It has user IDs as the props that have to be passed in. They're an array of strings. And so we have our component being created, this React function-based component with the generic being our props. Next we have the service. So we'll use services for kind of business logic instead of trying to have all the business logic into the page. A lot of the shared functionality, whether it's users, such as users logging in or logging out or doing all that kind of stuff, we'll use a, we'll call them services, and we have our service factory that can return created services. So we can kind of make sure we get the same one always back. We only have to create it once. And then we have in our order though, we'll have kind of our constant variables first. We'll have our React states first. So our use states would be second, after that, we'll have any use effects. So use effects will be third, and then we'll have any kind of custom generic functions in our component. Function handle click on user. And then I'm going to skip render data. That would be the next one, and I'll explain that in a second. But then we'd have our return statement right here. That would be the very last thing, and then finally we export it. So what is rendered user data? Why would we do that? Well, a lot of times some of the code that we might actually put in what's being returned is kind of messy, and we would just want it to make it really easy for the next person coming in to have to, or even yourself, months later, to quickly be able to look through the return statement, figure out what's going on, and then go to it. And so we solve that by kind of having these render functions. Now I know, the theory is that you could obviously make things into a lot of different React components, and then that would be even a prettier way of doing stuff. But a lot of times when you want to get at the same props or the states that you already have set up, sometimes we'll just make use of these render user data or these render functions instead of creating more React components. But if we look at this, what we're doing here is we're looping over the list of users. We're looking at them. We are, and then we're returning a user card from that. And so if I would have take that same code and thrown it in here, it just would have made it just a little bit uglier. And so again, that's why we're using these render functions. So here's the next kind of thing is one thing that you'll see a lot of people outside of RedSky will do is they'll take their props, like their name, and they'll spread them right here. Let's see here. If I come back to this example here, instead of passing props as a variable in and say they had a test of number, they will just kind of take that, because it's an object that gets getting passed in, they'll just spread it right here or not spread it, but decompose it into its actual things. And then you can use test down here, however you want, kind of thing. The reason why we don't like doing that is sometimes these functions or these components will get actually quite large, and you'll forget where did this test come from, and then you'll have to search around and say, oh, okay, test is up here, kind of thing. What we prefer is that everybody sticks with props there, and then when they use it, they'll see props.test, and that's just kind of a really quick visual clue. Ah, I see, it's props.test. And so that's what this section's talking about. The next is really just the main thing to clean code is just keeping your files small, your functions small, very descriptive names on what you're doing, and doing that. So again, this is what this entire component will look like once I remove all the comments of what we have going on before. The next thing I want to talk about is, and it's probably the last thing I'm going to talk about in this video, is our API interface structure. So with front ends and back ends, you have to have a very strong defined typeset between your front end and your back end in how values are being passed. And so we do that by having an interface file that is called, it's usually in the source folder, and it's an @types folder. We'll have a couple of them, but one of them is, for example, API .d.ts. And so this is a decent sized file, but what it does is it describes all of the values that you'll be sending back and forth between your front end and your back end. I'm going to quickly fold this whole thing, so collapse all, and then I'm going to expand it. So for example, I have this declared namespace API v2. Now this is obviously a TypeScript type of thing, but what it allows you to do is you can now do something like this, where you say let user is of type API v2 dot, and you can kind of see you get the autocomplete. So you get the user dot, and then we subdivide these even further into more and more namespaces, and one is the response from the back end and one is the request. So typically when you have a user object, it would be from the response from the back end, and it might be from a get response kind of thing. And so now I've strongly defined that, and I might have a function that says, get my user. But what's cool is now when you do user and you do a dot, you can have kind of all of the values that you might have from there. They'll autocomplete. That ensures that we have a very strong coupling between our front end and our back end, and we can follow the name spacing. So again, we'll have your API v2. You'll have, then it's usually the endpoint that you're trying to hit, like user or share or session. You expand that, and you'll have maybe some common types that are between the request or the response. But if I look at the request, I might have a login, and I can see that for the login, I have to send my username as a string and my password as a string. And that's just how we kind of keep in check the front end and the back end. Other types that we'll have is the models, and these models are usually, they're an exact one-to-one match to what's in the database. So we'll probably have an option table in there, and it'll have an ID column, a product ID column, and they're of these types that are in here. So models are exactly matching to the database. The final one that you'll sometimes see is kind of just this RedSky generic one, which we'll talk about. And so, for example, it might define that when we actually request something from the back end, it responds and it puts it into a data object. So our response will typically look like this, where you'll say data, and then inside this data might be the user object. So it'd be like ID of ID of 1, and it would be a name of Tim kind of thing. So that's typically how you'll see stuff being in there. Let's see if there's any other RedSky stuff. We have a kind of a pagination query and a filter query that'll be in there and stuff. So anyways, that's really about it. One thing I do want to say is when you're creating your components, one thing we do not want to do is ever add any margins outside the main component. What you should think about is a component itself is kind of self-contained. It's up to the page or the higher level component to actually position him around, add margins and stuff. So think of a component as just a box, and then your job as the developer writing the component for that box is you're just worried about the inside. So if there was a border on your box, you'd put a border, and then you'd pad it in if you needed padding, and then you just control the stuff that's inside of you, not even concerned about the outside world at all. So that's one thing that we'll definitely check on code reviews, is making sure you're not adding margins to your box itself. It should be the page. There's a lot of more things to kind of talk through with RedSky, but I hope this video was kind of a good introductory video, and will get you on your way to writing nice, clean code that kind of conforms to the way we do it at RedSky. Thank you.